Have you seen the back of a car? If you see it, there's a ultrasonic sensor. This helps the driver not to hit when the cars go backward, and I'm start thinking, can we use this system to human? My name is Matt Farm and this is my research Cliffy. People with disability have limited mobility in everyday life, or if they do outdoor activities, they will be worried if something happened to them on the street. From the research is expected to help the blind people to detect surrounding or nearby object and also provide a sense of security to user with its GPS feature. To resolve the issue, we make tool that contains some important components such as ultrasonic, GPS, gyro, and also C module. Cliffy is divided into two systems, a glasses system and stick system. We started development Cliffy from 2018 until now, and it's always updated until version 2 to get a more optimal result. First system is a glasses system. Cliffy has a 3 ultrasonic sensor and also 3 vibration motor. And this is what vibration motors looks like. This tool is connected to the motherboard. This is all the components installed. There are two potentials. The first is used to adjust the volume, while the second pot is used to change the mode. And this is a flowchart of a glasses system that we can see when the program starts. We can select mode we want by rotating the potential. Obstacle avoiding is divided into two languages in the system, English mode and Indonesia mode. We can select language already installed in SD card. There are no restrictions any language can be installed because the language audio file itself obtained from Google Voice. After selecting the language, Arduino will read data of each left, right, and front ultrasonic sensor and will check if any objects are detected. Arduino can say objects are detected if data received from ultrasonic sensor is less than 1 meter. This audio feedback is forwarded to a 3.5 audio jack that can be heard by the user. If we choose expert mode, vibration motor located in the glasses will vibrate depending on the distance of the object. When there is an object below 1 meter, the vibration motor will start vibrating at minimum speed, and if distance is reduced, the speed of the vibration motor will increase. The maximum speed of vibration motor is achieved when the distance of the object is below 30 cm. And this is a schematic of glasses system. Next system is stick system. If we look further inside this tool, there's a SIM, gyro, Bluetooth, Arduino Nano, and also GPS. If you look on the top, there's a call sensor and also battery case. On the stick, there's a two Arduino which have a separate circuit. It is expected each system work properly and normally. First Arduino is for read the RGB data and set it to the Bluetooth, and for the second Arduino is for handle the gyro sensor and send emergency message. For the color sensor is still not used into the system because it is still in development phase. And this is a schematic of stick system. Connection between two systems is using Bluetooth. First Bluetooth in the glasses system is set to a master, and the second Bluetooth on the stick system is set to slave, which will automatically connect when turned on. Cliffy has 3 modes. First and foremost is emergency message. Arduino will determine whether the user fell or not. If the Arduino detects the user falling, Arduino send emergency message containing the coordinate of emergency number. And how Arduino can say the user is falling? First, we do a simulation. We make a simulation tool that is same size as the stick. It's about 93 cm from the ground, and also we define the variable which we will use in some condition. Data obtained from the gyro as much as 20 samples per second. After doing some experiment, we can see on the existing graph that if the stick falls, there's an impact and increase of exertion. To determine the threshold, we will calculate the total exertion of the tool from the equation. After determining the total exertion, we simulate again to determining the threshold. From the result of the second simulation, we can set our threshold at 24 meters per second square because we can see based on the graph, the minimum exertion achieved by the object is 24 meters per second square. Okay, we have set our threshold, and what's next? Can we say someone fell on the path on the threshold? No, there's a problem found. We can see on the graph some steps exceed our threshold. If we only use the benchmark of the threshold, The program declares him to have fallen, when the fact it is not. How to solve the problem? We must make other most fulfill condition. When the stick falls, we know that there are only two conditions or positions of the stick that fall on the surface. For the first condition and second condition. Of these two conditions, we can see the two conditions have something in common. The acceleration on y-axis is 0. This is what we will also make a condition that must be fulfilled before the program says the user is failed. So, this is the algorithm. First, the total acceleration must exceed our threshold. It will be triggered to check the next step. After that, the thing to check is acceleration on y-axis. If the acceleration on y-axis is almost 0, then the buzzer on the stick will sound for 30 seconds. If that's all the time the stick is still in falling position, then the system will detect that the user has crashed. The Arduino will automatically send a message to the emergency number containing the coordinate of the user. We do accuracy testing of the tool, with two activities tested, throughput and working normally. We get a result above 85%. Most failures of this tool are not from a system failure, but a component durability problem, such as a module malfunction. Next mode is professional mode. We know it in the beginning, Cliffy has a 3 vibration motor. The vibration motor will rotate according to the distance to the object. The closer the distance to the object, the motor will move faster. Otherwise, if the distance is farther, the motor will slow down, so that the user can feel and imagine the location of the object around them by feeling the vibration of each motor. Next feature is obstacle avoiding mode. Because we have a ultrasonic sensor, we will get 3 different data. This data is what we will make into several conditions that can be read and distinguished by the Arduino. This tool will provide the feedback in the form of audio that can be heard by the user. In SMA Negeri 3 Bogor, there is a blind student whose name is Francisca. I've attached to her. I would like to thank you for helping me to improve this tool.
Welcome. I was created and programmed by Mohammed Farin. Please choose your mode by rotating the pot beside the tool. Standby. Expert mode. Indonesia. Benda di kiri. Benda di kiri. Belok kanan. Belok kanan. Benda di kiri. Benda di kiri. English. Object on the left. Object on the left. Turn right. Turn right. Object on the left. Object on the left. Expert mode.
This research is in the future able to help the blind people in doing daily activities as well, providing a sense of security. There are many shortcomings of the system, but we will always update until the system can work optimally as possible. My name is Sumat Mahar, and this is my research Cliffy.